Hello YouTube Vintage Stereo Restorers. Today on Basic Restoration of the KA-2000 we're going to just deal with the output transistors. I always check them very early on in the restoration. These are TO66 style. They look like a TO3 but they're smaller. It could be an NPN, it could be a PNP. These are NPN. These sank into SD91s. Are actually very durable transistors. They actually will blow, of course, if they're pushed too hard, but this is all the original and the same lot number 90, which is kind of cool. So I like to keep them. Purpose of this, twofold. One, sometimes the pins get oxidized and they don't make a good contact. There's only a little band of metal touching the pin underneath, a little collar. So by taking it out, you're actually cleaning it up a bit. Now there's going to be a plastic or mica gasket here. Yeah, there it is. This has some kind of lube on it, but it's not much of it left. What I do is clean it off. I use a lot of wet wipes because, well, I tried going really, environmental with using cloth wipes and vinegar cleaners and stuff. Trouble is, you pollute the cloth so quickly with different things. I find you're throwing out cloths. You have a whole bag of dirty rags that was going in the garbage versus partial bag of wet wipes. And the baby wipes are good. They're not too corrosive. So I just wipe around the socket there. There's hardly anything on this one. Let's give the transistor a light wipe. This one is actually labeled, I don't know if you can see it, B&E. Break and enter. I'm going to use, for testing transistors, I prefer an analog meter. Couple reasons for that. One is that it's actually testing them, like in a real circuit. Not going through a chip or anything where that means much. So you start with negative on base. You go to emitter, you should get about 20 ohms. About 20 ohms to collector, 15 to 20. And then what I do is I reverse them. Make sure there's nothing flowing that direction. That's where you'll find a leaky transistor when you reverse the leads. And finally put the negative on the case, which is the collector. Touch it both ways. So this one's still really good. I've used actual transistor testers. I have a transistor testing meter. It's an old Heath kit. It's not bad. You still have to take it out of the circuit. The only thing with it was, it would show a good transistor and then I put it back in and it wouldn't show noisy germanium transistors, for instance. Any of the smaller signal ones, there's C458s on this board, we'll get into that later, that have heavily oxidized leads, and they'll actually test okay, but in reality they'll be that kind of noise. So this one looks really good. So what I'm going to do is I'm just going to put it to the side and grab my grease. Boy, you get a lot of stuff in the workbench. So here's the biggest tip I can give you, the best advice I can give you in life. Use dielectric spark plug grease. This was put on to me by one of my teachers in electronics years ago. Think about this. This was in the very early 80s in one of my courses. And he said, don't use that white grease. That's yesterday's technology. That's 40 years ago. That white grease makes a mess. It breaks down. It turns into cement. And it's just, ugh. This has the same property, if I can get the lid off. There we go. So this is thermal grease. I'm just going to take the first bit, which is yucky. You just need a little dab on your finger. Massage it around the socket. Stick this back on. Like that. And put a little bit more. You can either dab it onto the gasket or onto the transistor, whichever is easiest to get at. Here's something I noticed on this. Usually there's a little insulator on the screw so it doesn't touch the side. You don't want the collector, which is the case, going to ground on this. It would be very bad. The transistor would last a millisecond. So what you actually want to do, so I'm going to test fit the transistor, make sure the leads are neat, straight. Back in. Here's how I determine if you actually need something on the screw. If the hole lines up right over the threaded portion below in the socket, you really don't need anything on that screw. Sometimes though the socket's a little bit out, transistor's a little bit out, or it's a smaller hole, then I would just take a little bit of shrink wrap tubing and put it on the threaded portion. See, that's right there. It'll be nowhere near, but we can actually test it too. Just take those down. How tight? Well, even tightness is good. There's an answer. Just take it down evenly. Screw stop turning there. I don't go crazy tight. Get it down. We're down to like 1/8 of a turn. 1/8 of a turn. With finger torque, you should just get to the point where the screw stops. You don't need to go. Rrr. So, we got that one back in, and you can wipe off the excess. And then what you do, you put the meter somewhere like that where you can see it. Touch it to ground on the chassis, and just touch the screws. What you should see is a slight reading. So there's 40 ohms there, so it's actually going through one of the resistors to ground. If it were a short circuit, of course it would go right to 0 on the meter. Test it the other way. Nothing. So that's good. That one's done. And you know, it's the same thing. What I like about these is they're not soldered to a board anywhere. I'll show you what's underneath. Some of them in later units, they would use TO220s, which are the black chiclet types with a tab and a screw, and they'd be soldered right to a board. And sometimes I've come into them where they've been changed a few times. What a disaster. But there is a fix for that. So the sockets are down here. You can see the screws that hold the sockets down? So what I'm going to do is just make sure those are snug. They're kind of loose. Think about how many heating and cooling cycles over the years, right? So there's the TO66 sockets, which are just a small version of TO3. So then I'm just going to go along and do each transistor. Then I know it has some good thermal grease on it, and I've tested them all. That's all for now. Thanks. Going to keep this one short. Thanks for listening.